Hey everyone. Now here's the plan. First of all, I'm going to sell the Tesla, right? It's for sale, so buy it if you want it. Secondly, I'm going to buy a van and I'm going to deck it out for a camping van and I'm going to go camping around Australia. That's the plan. Now I don't have the van yet, but one of the things I can do is start planning the network. And core to that network will be this Raspberry Pi Zero W. So what I'm going to do is set this up with a few funky features and get it ready for when I do get the van. Now the first thing I want to do is set this up as an access point so that wireless clients can connect to it, okay? Because I'm going to have the MacBook, God knows what else, and the Dashcam, okay? So they're going to connect to this as their AP. Also, this is going to be a wireless client itself to other APs, depending on where I am for its uplink to the internet. And of course, when I do that, this has only got one radio in it, so it's going to act as a wireless client and an access point in one. So the bandwidth that it'll use in the RF space will essentially double. So it's not ideal, but it will do the job for what I'm going to use it for, which is just a bit of data connectivity. So I'll do that now. Okay, there's a lot of things I've set up on this, so I'm not going to get into it in great detail. I'm just going to brush over the main things that I've installed and what you have to do. So firstly, for the access point and the wireless client, I followed a page online here that I'll put the link in for. And here it is. So even though it's a few years old, it still works for me. So you should be right with that. So the first thing you've got to do is add the interface for the access point. So on the Raspberry Pi, go into etc udev rules. And if you have a look there, you would have had this 99 com rules, but we'll add this one here, this 70 persistent net. And just put this in. Now what we're doing here is change this to the MAC address of what you've got as your wireless interface on this. But we're setting up a new IEEE 802.11, which is Wi-Fi interface on that physical interface there. And we're saying to add one, and we're calling it AP0, and the type is AP. So that gives us an actual interface to set up as an access point. Next thing you've got to do is add a couple of programs. So apt-get install, DNS mask, and also host APD. I've already installed them, so I'm not going to do it again, but DNS mask is the one that is the DHCP server for the clients and also the DNS server for them, okay? And host APD is the program that runs and controls the access point itself. So you've got to install those two. The next is a bit of config for the clients there, so when they connect, they get their IP addresses and stuff. So in etc, you've got this dnsmask.config, and if just leave most of that as it is, but right down the bottom, we've got some custom stuff. I'm just telling it to use AP0 and where are we? The server. Now the server is the DNS server. Now I'll come back to that because you'll see why later on in the video, but that's where I define what DNS server the clients will use. Now the range for their addresses I've just set there. Okay, so you've got that range for them. And I've set a couple of static ones here for some of the devices that I'll have. Because I'm going to test this out with the Dashcam that I've currently got, and just like I would in the van when I get it, and also a MacBook and a phone. So I've just added them there, but you don't have to do that. Next is the config for the access point. Okay, so we need to tell it what SSID, the network name and the password and that. And that's done in etc hostapd hostapd.conf. Okay, so for me, country Australia, interface is AP0 that we created. I just called it the SSID, call it whatever you want. This and that, it's only got I picked channel 11, blah blah blah, a few other things. And this one here are the rates. Now, in all wireless deployments, I like to turn off the low speed bit rates. I can't do that on this, even though I've set the config in there to start from 11. That's divided by 10, so it starts at 11 instead of 1. It's not actually taking effect as I confirmed with a packet capture. I don't know why that is, but it doesn't actually bother me when it's going to be in a tin can van and just me. So that's just that. And the BSSID is the MAC address that it will broadcast. So you can pick something you want there. I've just happened to pick that. And that's about that. Okay, next thing is the config for when this is a wireless client, for when it connects to another AP. So that is in etc wpa-supplicant.conf. Now you can see here, not much to it. I've just got two SSIDs set up, one for home and one for when I'm out there using the phone. And I've just given them names, home and mobile. Okay, next is to set up the IP addresses of these interfaces, and that's just done in etc network interfaces. So this is what I've got set up here. We're setting this up for the access point and the wireless LAN client that this is. Okay, so we're saying yes, make sure it happens on AP0, which is the AP, the access point. set this IP address here. Now, together with that net mask, you may recall when I had the DHCP scope in dnsmask.conf, it falls within that network. So the clients that this gives addresses out to can actually talk to the access point here. Okay. Next is WLAN 0, which is when it's a client, and those two networks that I set up, home and mobile, just says use DHCP for them. Okay, so there's a couple more things we've still got to do. When the clients connect to this AP, we want to make sure that not only do they get an IP address, but they route through that and get NATed so that can use the uplink as their internet connection. So, we've got a couple of rules here. First of all, we've got to reset the interfaces. So we take down wireless LAN 0 and AP 0, both the interfaces on here, and then just bring them back up again in that order, and that makes it happy. Next, we've got to turn this Raspberry Pi into a router, and do that with this command here. Okay, so that IP forward means it'll send packets from one interface to another, whereas it wouldn't do that if that wasn't set. So you've got to do that, otherwise it won't be routing. And the last one is we're doing some NATing, that's network address translation, on the interface that's coming in. If you remember, that's the subnet for the clients connecting to the AP. And the masquerade part means it does the NAT and sends it out. Okay, so when you connect to something, it'll do your network address translation and access what you're doing, send the traffic back to where it came from. So that's pretty much it at this point to get that to be an AP and a wireless client itself. So here it is. If I have a look at the IP addresses on this thing, you can see what I've got. Okay, wireless LAN 0 got an IP address from my home network here, 192.168.1.32. That's good. That's how I'm connecting to it at the moment, obviously, because it's just on wireless and I'm connecting from this thing. The other one is the access point, 192.168.10.254. And if I have a look on the old MacBook here, I'll be able to connect to that. Okay, so here in the MacBook, if I just have a look at my network interface here, I see that I did indeed get the address that I reserved, if you remember. So I can now ping Google and whatnot, or ping it by name, and there it is. Now if I have a look at my routing table, was that Fairly, iNet, that'll do. You can see my default gateway is 192.10.254. If I look at the DNS server that I got, resolve.conf, you can see it also got the same one as its DNS server. So this client is going to use this address as its DNS server, which of course this will use an upstream one. Okay, so that client works, data's going in there. Now one thing to remember is this radio, there's only one radio in here, so it has to do the client side and the AP side. So it's got to share that same channel. So the throughput is going to be pretty much half of what it would normally be. Okay, and we can show that with TCP dump, but actually I can't be bothered, just trust me. And if I have a look at the spectrum, as it's just sitting here, you can tell I'm obviously on channel 6. Now I'll just do a simple speed test on the laptop here to show you how slow it really is. I have done iPerf tests, which is how you'd really test this. So between here and the server is just a bit over twice as quick as from here via that to the server. But anyway, just doing this here, you get, what, 10 megabits a second. That's plenty to do stuff. Okay, it's going to be the same on the uplink. So as you can see, the RF's getting smashed because it has to do both, but that's expected and it will do the job anyway. If you had a 10 megabit per second internet link, you can still do your email, still watch high def stuff. And the reason I have a TV server on the network here, even though I don't watch TV, is for things like this. So for testing stuff, I just want a video stream, and I can see that the quality is fine. So it can pass a video through here without a problem. I can do high def video. It's not a problem. I wouldn't expect too much more out of this thing, but considering what it's doing, it's not bad. Okay, so we're doing well, but we can go further. And I just happen to have a USB 3G, 4G thing, okay? Little cable here to plug it in, and I can plug that into the Raspberry Pi and get yet another interface. So I'll do that and reset the Raspberry Pi. Okay, I've got no reception inside the house, so I'm just going to set it up near the open door here, and I'm going to power it off this battery pack. Okay, just for now. Boot that up. Just sit it there. Okay, there really is no reception around this place, so what I'll do is take it outside. throw it up here on the aircon and see what happens. Okay, so it's found the mobile network, and it's flashing means it's ready, and now it's soldered on, which means it's connected. Now it's on 4G as well. So I'll just leave that there while I go through this inside. Okay, so I'm back in here, and I've connected up to it again, obviously through the wireless network. And if I have a look at the addresses now, you can see I've got this extra interface, this wireless WAN. Okay, this is the one I had before on my network. This is the access point, and that's its network there, and any clients will be on that network. And it's also got this wireless WAN interface, and that's its IP address there. So that's pretty good so far. If I have a look at the routing table, just show you the routes, what you'll see is I've got two default routes, okay? Because this has an uplink to the world, and so does that one. This one here is just for the wireless clients from its AP, as shown there. But for the two default routes, you can see that this one's first, okay? And it's going to use that in preference to the mobile network one, and that's because of the metric, okay? Because that's a higher number, it'll be lower down on the list, okay? The shortest way is through this one, so that's what it's going to use. So what can I do with that? Okay, so one of the things I can do is ping the Dashcam, because it's one of the clients of the access point there. Okay, and another thing I can do is I can send a port forward through. So if the Raspberry Pi receives traffic from a certain port, I can forward that through to a specific IP address like you do on a home router. So what I've done is I forwarded a port and sent it through to the Dashcam. So what I can do now is look at the Dashcam even though it's behind the NAT there from access point 0. So that's all good and well. We're getting somewhere. Okay, so I've got a bit of traffic getting around now. And what I noticed when I did this is when the Dashcam associates to that this AP here, it's a Blackvue Dashcam, and even though it got told what DNS to use, okay, got told to use 192.168.10.254, the AP itself, it was actually disregarding that, even though it got that from its DHCP, and it chose to go to Google and Cloudflare. So it was disregarding what I was saying, but I'll come back to that again too, because what's coming up next is a VPN. Okay, so we've got the interfaces on here at the moment. Okay, IP link. You can see I've got the wireless LAN, the wireless WAN, and the AP. And as I said, if you show the addresses, you can see them all there. Okay, bang, bang, bang. I'm going to add a VPN to this, which I've already done, so that this will start a VPN to the house. So I'll just start that up. etc init.d, open VPN, start. Okay, cool. Now, if you look at the interfaces, I've got this extra one, this tunnel interface. And if you look at the IP addresses, you can see now I have an extra IP address here. Okay, so that is a VPN connected to the house. I've even done a diagram to show you what I'm getting at here. So here it all is in its current form. I've got the van, which is the Raspberry Pi. It has four interfaces. It has its wireless LAN, which could be a client of any wireless network, just happens to be at home at the moment. The wireless WAN, which is the mobile network. The AP0, which is the access point, and I've got two Dashcam clients at the moment, but that would be the MacBook as well and whatever else I connected this thing out on the road. And now that OpenVPN has started, I have a VPN tunnel to the house. So the only actual connection into the house from this is UDP 1194 for OpenVPN. But what I can do from my home's WAN connection, I can have an incoming port go in there and forward that through to the tunnel. And when the van receives it, forward that through to the Dashcam. This now gives me access to the Dashcam wherever I am. So if I'm out on the road, I could let someone else see live what I'm seeing out of the front windscreen. Okay, now obviously this Dashcam's sold with cloud, which anyone who I know in IT hates the word cloud. But the cloud in this sense is my home, so there's no middleman. Rather than paying for cloud access so you can access your Dashcam when you've still got to use your mobile internet anyway, I'm just doing my own VPN to my place rather than some company's place, and then I control it then, so I can look at it whenever I want. Now, the other reason I mentioned DNS before was I'm telling these Dashcams to send their DNS down the tunnel to Pi-hole, which is my own DNS server, which blocks ads and things, so that when it tries to do anything, it just gets told that it doesn't exist. So that saves a bit of bandwidth as well. And also when I've got clients on here and I'm looking at web pages or whatever, I still resolve their DNS at home, but not ads. So it cuts down on actual bandwidth use as well. So it keeps all that to a minimum. So there's the whole setup so far, but there's still more. But for now, I'll just do a bit of a live demonstration and see how this goes out there in the real world. So I'll set up the laptop somewhere. I'll get away from the house completely so there can be no confusion that I'm not connected to this home network locally. So I'll just do something out there in the wild and see how we go. Okay, so what I've got set up here is a hotspot on the phone here that the laptop's connected to, just so I can be on the internet proper. And that's connecting to my home, and it's going down that VPN tunnel to the Raspberry Pi in the car, and it's using its local mobile network to send the traffic back. So I'll just do a little drive around here, and you should see something change on the screen if it's not too dark. Should have seen something change on the laptop here. Hopefully probably still on. Yep. You can still see the clock ticking, so I guess it worked. Okay, so the mobile reception wasn't that good out there, but you get the point. Now something else I can do, given that I've got a VPN connection from this to my home network, is run SNMP network monitoring. So I've added it to LibreNMS over here, so I can keep an eye on specifically the traffic through the different interfaces, like the mobile network, to keep an eye on how much data usage I've got. Another thing about this little device here is that it's got a little card reader. If you can see that, it's got a little micro SD card reader. So I can use that as an extra drive rather than thrashing the SD card that's in the Raspberry Pi. So that's pretty good. And there's one more thing that I haven't really done too much of with this, but I have seen that it's got it, is a GPS receiver. It's actually got a GPS receiver in here, so I may muck around with that. I may not, but they're quite interesting little pieces of kit, and they're pretty versatile. Okay, what I'll do now is a quick iPerf test. Firstly, just from this to the iPerf server, and then from one of its wireless clients through it to the server. So just from this thing itself, let's see, 768 megabits a second. So not fantastic, but as I showed, you can still get video through on that, so it's livable for the purpose of what it is. See it smashing the RF there, of course, because also the receiver's just down here, so it's really going to hear it. Okay, so that's about what I was getting from just this to the server. So if I use one of the clients now, through that, you get 6, 4, 5-ish, around 5 compared to around 8-ish, 7 or 8. So it dropped a couple. It didn't halve it though, which is pretty good. So the clients here, they can get at least 4 megabits a second, which, okay, sounds slower than a real network, but it's usable. So it will serve the purpose of what I'm after. I'm not going to stream video at that rate. Like the video that comes from the Dashcam is not high-def video, which I can pass through that bandwidth anyway. So it does the job, and it does it pretty well. Now I have used this SIM card and a Raspberry Pi to send and receive SMSs, but the problem is once Network Manager takes over that TTY interface to control the modem, I lose control of it for an SMS machine. So I'll have to figure out if there's a way around that. If you know one, let me know. But there's heaps of other things I could do with this. I just haven't got around to it. But it is handy to have, and it's that big. So it won't take much space in the van. And also it doesn't take much power. I did run it off a PoE port and just checked how much power it was consuming. And I can't remember what it was, but I do remember it being close to nothing. But it did go up to slightly more than close to nothing when I did an iPerf test through it. But really, it's not going to get much better than this. So that'll do for now. Once I sell the car, I'll get a van and we'll continue this and see what I can do in it. So buy the car and I'll make another video. See ya.